So, what if I told you there's a hidden penalty on your facility's energy bill? I mean, a silent budget killer you're probably paying every single month without even realizing it. Well, in this explainer, we're going to hunt it down. I'm going to give you the tools to find it, fix it, and start saving some serious money.
So, what exactly is hiding on your bill? Look, it's not the usual taxes or fees you can't do anything about. No, this is a penalty for electrical inefficiency, something called a poor power factor. Now, I know that sounds super technical, but just forget the engineering for a second and think of this purely as a financial problem that, believe it or not, we can actually solve.
All right, here's our game plan. We'll start by defining the problem, then I'll show you exactly how to calculate your own power factor just using your bill. After that, we'll talk about finding the right fix, and maybe most importantly, we'll look at the financial payoff. And finally, we'll wrap up with some key practical things to keep in mind.
Okay, so what is this power factor thing really? Well, to get it, you first need to understand that you're actually paying for three different types of power every month, but only one of them is doing the real work you care about. First up, you've got active power. Just think of this as the good energy. It's the juice that actually gets the job done. It spins your motors, it lights up your facility, it runs your machinery. This is the energy you want and expect to pay for, and it's measured in kilowatts. Next, we have reactive power. And this is where the inefficiency starts to creep in. See, it's energy that things like motors and transformers need to operate, but here's the kicker. It doesn't actually do any useful work. It just kind of circulates through the system, putting a strain on the entire grid. And that brings us to the third type, apparent power. This is the total amount of power your utility has to generate and get to your doorstep. It's the combination of the useful active power and that less efficient reactive power. Your whole electrical system, from their transformers to your wiring, has to be big enough to handle this total amount. This slide really sums it up perfectly. The key thing to remember is this. Your utility has to supply the total apparent power, even the inefficient part. And that's exactly what we're here to fix. And this brings us right to the main event, power factor. It's simply the ratio of your useful active power to the total apparent power. Think of it as an efficiency score. A perfect score is 1.0, which would mean all the power you draw is doing useful work. The lower that number gets, the more inefficient you are, and the more likely it is your utility is charging you a penalty for it. All right, let's get practical. It's time to actually calculate your facility's power factor. And you don't need any special equipment for this. Seriously, just go grab your latest electricity bill. It's just a simple two-step process. First, we're going to figure out your total apparent energy. Then we'll use that number to find your power factor. All you need to do is find two numbers on your bill, your total kilowatt hours, or kWh, and your total kilovolt ampere reactive hours, or kVARH. Okay, so here's the formula for that first step. We take the square of our kWh, add it to the square of our kVARH, and then we find the square root of that whole thing. I know it looks a little intimidating, but it's really straightforward. Let's just plug in some numbers so you can see. So let's say your bill shows you used 1,000 kilowatt hours and 600 kVAR hours. Okay, so we square 1,000, that's a million. We square 600, that's 360,000. Add them together, take the square root, and we get about 1,166 kVH. That's it. That's our apparent energy. And now for the final easy step. We just divide our active energy, that's the kilowatt hours, by the apparent energy, the kVAH number we just calculated. So using our example, we take our 1,000 kilowatt hours and we divide it by 1,166 kiloVA hours, and the result is a power factor of approximately 0.86. So what does a score of 0.86 actually mean for your wallet? Well, most utilities start hitting you with penalties when your power factor drops below 0.90, sometimes even 0.95. A score of 0.86? Yeah, that almost guarantees you're paying extra on every single bill. Okay, so we've found the problem and we've measured it. Now, how do we fix it? Well, the most common solution is to install something called a capacitor bank. And believe it or not, we can calculate the exact size you'll need right now. Now, this is the formula engineers use, but please don't get hung up on the math. All this really does is take your current power consumption, compare your current inefficient power factor to the target efficient one you want to reach, and it spits out the exact size of the capacitor bank needed to bridge that gap. So for a pretty typical 500 kilowatt facility,
Trying to get from that inefficient 0.86 up to a nice, clean 0.95, this is the answer the formula gives us, a 132.5 kVAR capacitor bank. See, this isn't just some random number. It's the specific, actionable solution to stop those penalty charges cold.
So what's the business case here? I mean, why go through all this trouble? It's simple. Correcting your power factor is very likely one of the best and fastest returning investments your facility could possibly make.
Just look at the impact here. Imagine your facility has a $10,000 monthly bill, and a full $2,000 of that is just penalties for poor power factor. The moment you install the right capacitor bank, those penalties just vanish. Then you factor in the reduced energy losses, and the total savings here could be around $2,500 every single month.
And here's the real bottom line. The payback period? In some cases, it can be as short as 5 months. Even a more typical payback of 6 to 12 months is an absolutely incredible return for any kind of infrastructure upgrade. It's almost a no-brainer.
And the savings don't just stop at the bill. Think longer term. You're making your entire system more efficient, which means less wear and tear on your equipment. You're also freeing up electrical capacity, which could let you delay an expensive and disruptive system upgrade way down the road.
Okay, before you rush out to buy a capacitor bank, there are a few real-world things we need to talk about just to make sure the solution is robust and really effective for you.
So, a few final tips to get this right. If your energy load goes up and down, use averages to avoid getting the wrong size solution. Use your actual network voltage for accuracy, not just a textbook number. And plan ahead. Add a little safety margin, say 10 or 20%, for future growth. And finally, just be aware that modern electronics can create a different kind of electrical noise called harmonics, which might need a more specialized fix.
One last practical tip, where you find this data can be a little different depending on where you are. In a lot of European countries, the kilowatt hour and kVARH values are listed right on the bill, plain as day. In the United States, you might need to actually call your utility provider and ask for that data. Just something to keep in mind.
You know, I think this quote from our source material really just sums it all up perfectly. Taking the time to understand and correct your power factor is one of the most direct and financially rewarding actions you can possibly take to improve your facility's efficiency and, of course, its bottom line.
So I'll leave you with this one final thought. Go grab your latest electricity bill. Take 5 minutes and just run the numbers we walked through today. The crucial question is, how much money is your facility leaving on the table every month?